This is the second video on explaining how to find a moment of inertia using integration. Remember, our moment of inertia, I, is equal to the integral of dm times r squared. Okay, so I have a rotating disk, radius of a. Why don't we just say let a equal r, and we're going to find the integral of the dm for this. Well, now we're going to identify sigma. Sigma equals mass over area. Okay, so that's our definition of it. But what is the area, okay, of a circle? Well, the area of a circle is pi r squared. So what we're going to do here is rearrange this to find m. M, of course, is equal to sigma times area. And then dm, of course, is equal to sigma times dA. Okay, so pretty easy for us to find. So what exactly is that? So dm is equal to sigma times the derivative of pi r squared. So I'm going to put this in parentheses because I'm going to take the derivative of this. So dm is equal to sigma times 2 pi r. Now what does that equal? Well, there will be an infinite number of circles, of course, here. Okay, and we're going to multiply this times dr. So what does this mean? Well, I've got a circle here. I'm basically finding the area of a ring. So I'm trying to draw another ring just outside of it. Trying to do that. And the thickness of this is dr. So we have the area of this ring here that we're going to integrate from 0 all the way out, okay, to r. Okay, so I have this expression here, sigma 2 pi r dr, that I'm going to put in for my dm here. So my integral here then is equal to integral of 0 to r of sigma 2 pi r dr times r squared. Okay, now let me combine like terms and get the constants out of this. So I is equal to, looks like we have a sigma 2 pi, okay, and I've got an integral from 0 to r, okay, and it looks like I have r cubed dr. Okay, so now I'm going to take that integral, and then I've got outside here, and I'm just going to say I equals, I have sigma 2 pi. This is going to be, of course, the integral of r cubed is 1/4 r to the 4th under the definite integral from 0 to 4. All right, so what does this equal? To save space, I'm just going to look at this right here. So I have sigma, I have 2 pi, okay, and this is then going to be multiplied by 1/4, okay, and what do I have here? R to the 4th. Well, now I need to put in for sigma, okay, what sigma equals. It's mass per area. So I'm going to do that now. So equals, my mass per area is mass over pi r squared. Okay, and if we want, we can maybe simplify this down here to just 2. Okay, and that's going to be multiplied by pi over 2. And then, of course, maybe I better put parentheses around this. And this is going to be times r to the 4th. So what are we left with? Well, we can cross this out. Cross this out. We have an r squared. This can cross and make that one r squared. Okay, so, and I'll write this in a space we can see it, maybe over here. Our final answer is I is equal to 1/2 mr squared. And that's how we do integration to get the moment of inertia of a rotating disk.